Welcome to the Thursday Algebra 1 video. Every student should have their note sheet from yesterday, which would have been in that big packet of notes. If you do not have yours, the sub will have extra for you to hand out. You will also need a graphing calculator. Make sure you have those. And let's begin. We're starting on example 3. So go ahead and turn to your note sheet to example 3 where it says correlation. It'll look exactly like this. We're going to have our first discussion about what correlation is in this class. You might have heard the thing causation versus correlation, or two things are correlated. What is correlation? Well, correlation is how much one variable is related to another. You can also think about this as how much one variable predicts the other. What does that mean? Well, you could say that being wealthy could predict that you have a big house. That might be a big correlation. If you have a lot of money, that might predict how often you have a big house. It might not. Maybe you have a lot of money and you have a small house, but that would be one way that two variables are related, where one variable is the amount of money you have and the other variable is how big your house is. The correlation coefficient is R, okay, and R states how much X will predict Y. So what that means is that X will sometimes predict what Y is. It will have a slope. And that value can go between -1 and +1, where 1 is a perfect fit. It's a percent fit. So I know I said something slightly different yesterday, but this is a percent fit. So what that means is that it'll give you a percentage of how well X and Y fit together. Okay? So we talked yesterday, depending on what class you're in and how far we got, whether these dot plots are correlated. And you could see pretty clearly that there's a relationship in the first one. I could have sort of a line that goes through these points, and they're pretty related. The dots are very close to lines. This is a pretty good fit. What I would say is that since these dots are relatively close to the line, that my R value, how much the X value will predict the Y value, is pretty high. It's not a 100% fit, but I'd say it's pretty close. I would guess that R is probably about 80, 0.80. Now notice I have a positive value, but my R can be negative. R can be negative when the slope of the line is negative. So this is an even better fit, I would say. And I'm not perfect here, so the line isn't completely straight, but it looks like a pretty good fit, but it has a negative slope. So I would say this one is probably about -90%, 0.90. How about this one down here? Stronger or weaker? Looks pretty weak to me. The dots are very far from my line of best fit, so I'd say R is probably close to 40%. Probably not very good. It's positive, but it's not great. And even down here, if we skip ahead and do this one, that's an even worse fit. I'd say R is probably like 20%. And for these ones, since all of these lines have negative slopes, I have negative R values. Okay, so this would be probably negative. It's a little better than this one, so maybe -60 or -50. This one would be probably -30, I would say. It's a bit better than the one on the left side, -0.30. Now let's answer these questions over on the right side. When is the value of the correlation coefficient positive? And that's when the slope or relationship is positive. And then obviously it's negative when the slope or relationship is negative. Is the linear relationship stronger when the correlation coefficient is closer to 0 or closer to 1? Well, 1 would be a perfect fit. So I would say that it's going to be stronger closer to 1 or -1. So now you should have this part of the page filled out completely. We'll move on. Example 4, we have an example that has Consumer Reports publishing a study of fast food items. The table and scatter plot below display the fat content in grams and the number of calories per serving for 16 fast food items. Each one of these rows is a fast food item, and they list their fat and their calories. And we're curious, is fat content related to calories? You see there's a scatter plot here where the x-axis is fat, the y-axis is calories. Based on the scatter plot, do you think that the value of the correlation coefficient, which is the R percent fit, between fat content and calories per serving will be positive or negative? Explain why you made this choice. Well, it looks like that as my fat content goes up, my calories are also going up. I can maybe draw a line that looks something like this. Again, I'm just guessing here. I'm not sure exactly what it is. Based on the scatter plot and the line of best fit, I would say that this is going to be positive. As fat goes up, so does calories. So as one variable increased, the other variable increased, which indicates a positive slope, a positive rise over run. As calories go up, so does my fat, and vice versa. Based on the scatter plot, estimate the value of the correlation coefficient. What would you think R is going to be close to? It's not a great fit, but it's definitely positive and it's definitely related. I would say R is probably about, I don't know, 60%. That's my guess. Now, we can actually use a graphing calculator to figure out what R is. This is going to require you to take out your graphing calculator, and the sub should have handed out a sheet that gives you the steps. Now, we're looking at the bottom half of that pink sheet. So it should stay on the top, creating linear and exponential regression calculators. The first thing you're going to do is hit the mode button. And the mode button is right here where my cursor is. You're going to hit that mode button, and you're going to see a menu that looks like this. And what you're going to do is you're going to scroll down where you see this next thing, and you're going to go to this screen. So scroll down now through that mode menu. Get down where it says Stat Diagnostics. Should be on the second page. You have to scroll through all these other options with your arrow key and go all the way down. Now my calculator is going to look different. So when I hit my mode, well, actually mine looks okay. But you'll have a next menu. You're going to go down next. I can't go past next, but you can. And you're going to get to this menu here. You're going to make sure you turn Stat Diagnostics on. That's going to get us our R value. Okay, so make sure your Stat Diagnostics is on. I'm going to give you about 10 seconds to make sure that happens. If we need to pause the video, please go through, and if people are having trouble, make sure everybody has gone to the Stat Diagnostics menu. I expect your partners to help you out. Once you have done that, and Stat Diagnostics are on, you go back to your calculator, and you're going to go to the Stat menu. We're going to step number 2 on your pink sheet now. We hit Stat, then we'll Edit, and notice that L1 has stuff in it. What you're going to do is you're going to clear that out by going up to the top. So notice how I did that? I just used the up arrow. You're going to click Clear, Enter, and now all the stuff is gone. Then you'll have to enter in all the data from my table that I had in my flip chart or in the notes here. So in the L1 menu, I'm going to put the fat. In the L2 menu, I'm going to put the calories. So I'll put the fat in there first, 2, 5, 3, 3.5, 1, 2, 3, 6, 3, 5, 3.5, 2.5, 0, 1, 3. So I think I might have missed one here. Let's double check. 3, 1, 0. Oh, I missed the 2.5. There it is. So notice how I went back and I checked. I knew I had to have 16 things, and I forgot this 2.5. It doesn't matter what order the number's in as long as you have all of them. You go back and check to make sure you didn't mistype. I think mine look okay. Now in L2, so we'll give you 5 seconds to get caught up here. In L2, what you're going to do now is you're going to type in all the calories. So I'm going to do 268. Looks like 303, I think. My thing's a little pixelated, so I'm going to put that in there. 260. Oops, looks like I forgot to drop my volume. 315. And I'm not going to narrate this anymore. You can pretty much type it in yourself. Just double check. And again, my answers might be different if I typed in my numbers wrong, if I can't read this very well. I'm pretty sure these numbers I'm typing in are correct, but I could have made a mistake. Okay, another thing I can check is I'm checking the x's and y's, making sure they go together. That looks like 290, 285, 390. And you notice this takes a little bit of time. You're probably faster than I am because I'm typing on the screen. You have it in your hands. Oops, see, I made a mistake. I need to go back up there and type that again. 330, 120. I think that says 180. I'm hoping it's 180. So I typed in all my stuff. My fat is in the first column. My calories in the second column. I'll go to step 4 now. So you're going to turn to the back page of your pink sheet. You're going to select stat again. You're going to go to calc menu. So you scroll over to the right. You're going to go down to LINREGAX plus B. So it's number 4. So you can scroll down, enter. Now your screen will look different. Your screen's going to look like this one. L1, L2, frequency list store, regression equation, calculate. You're going to scroll all the way down and hit calculate. So you're going to hit enter and calculate. I just have to hit enter once here. Uh-oh, looks like my R didn't show up. Your R should show up. If this happened to you, you have to go back and turn on your stat diagnostic. You should have these R things down here. I'm going to go ahead and turn mine on quick using a slightly different method, but it's the same idea. Second, catalog. I have to go to stats, so I'm going to hit the S button here. Scroll down to stat diagnostic. I have to turn mine on a different way, so just give me a second here. I want to turn mine on. Oop, I think I have to go to, actually I have to go to diagnostics on. I might have to just, oh, I went right past it. Thanks for being patient here. Turn diagnostic on. Perfect. I'll do that the whole process again of getting the line of regression, stats, calc, linear regression AX plus B. Now I have my R value. Looks like my R value was even less than I suspected. Looks like it's 0.27. Okay. I can actually show you what the stop plot looks like. Looks like it's pretty close to what I have on the screen. Not a great fit. So the R is actually about 0.27. Interpret this value, that means it's a 27% prediction. So at 27% of the time, the fat will predict calories. Okay, we go to the next slide here. The consumer reports also collected data on sodium content in milligrams and number of calories per serving. So now instead of fat in calories, I have sodium in calories. Now I'm definitely not going to be able to read those, but we can answer these questions here. There's an approximate line of best fit. Based on the scatter plot, do you think the value of the correlation coefficient is positive or negative? Looks like a positive slope. So it's positive, and that's because it's a positive slope. Estimate the value of the correlation coefficient. I think this is actually a better fit than the fat, which is weird, but it looks like that's true. So R, I would guess, is probably better. I'm going to guess maybe 40%. I was off last time, though. Maybe I'm just too optimistic. Let's calculate the correlation coefficient. I'm going to pause the video and just type in all the data. You should type in all the data, too. Remember that you're going to have to go back into the stat edit menu, and you have to clear out all this stuff. So I'm going to hit clear and get rid of that stuff, and I'll show you again. You get to move to your L1 column, use the up arrow, hit clear, hit enter, and now it's all empty. I'm going to enter in the data. Now I've typed in all my data. I'm going to calculate my R value. Okay, and to do that, I hit stat, calc, or linear regression AX plus B. You're going to scroll down to calculate. Now my R value is way better than I thought it was, 78%. Now make sure I round it correctly, 79% actually. R is approximately 0.79. It's a much better predictor. Sodium predicts calories 79% of the time.